Do you know that you can use human language to control your robot? Before we start, make sure that you understand how to use robotic operating system. The way it works is really simple. So first, the system will receive the commands via text message, and the commands then will be parsed by the AI agent tool, and the parsed commands that will be sent using HTTP request tool. And the address here is actually the address of my laptop. I'm using ROC, and by using ROC, then I will expose my port to the internet so that my personal laptop that has the simulations, which in this case is nvidia IsaacSim, will be able to communicate with n8n through this specific port that I opened. And then once we got the once the command is executed, then it will send a message via Teams as well. Okay, let's give it a go. So first thing we need to do is we need to execute the workflow, and then we can send a command by saying move forward, please. Okay, let's have a look. It's executing, and as you can see that it's gonna have to wait a little bit. Okay, it sends the command, and then robot now is moving. Let's stop it, and to stop we're gonna execute the command, and we're gonna say stop. Okay, now the robot is stopping. We can also send another command. Let's say rotate left. Okay, yeah, it's executing. Okay, then I'm gonna say stop. Okay, I forgot to execute the command. Let's execute the command, and then I'm gonna say stop. Okay, it's very slow at the moment because I've got cameras from the robots. They are streaming, but this is actually good for us because this type of command is really slow anyway. Yeah, and there's another feature that I have in here as an experiment. So we got a couple of cameras. Let's say if I click the front cameras, okay, so it's gonna look at the floor, and if we so basically what happened here is by using robotics operating system 2, I streamed this data directly, and if we go back to our n8n workflow, we can actually ask the robots about what they see by using this image analyzer from OpenAI. I think let's go ahead and try that. Let's ask, what do you see? Okay, click enter. Then okay, so it asked me to fetch robot data. I think that's the command that I specified. Let's try again. I'm gonna execute the workflow and ask it to fetch the robot data, please. Okay, let's see. Okay, it's running and it's calling this tool, and okay, sending the reply by saying the robot that has been fetched image shows minimalistic scene of the flat textured surface with a faint red line running diagonally. Yes, that is actually true, this one. Let's get the robot closer to the more interesting objects, and let's try the image analyzer again one more time. Okay, now that we are at more interesting objects, I'm gonna execute the workflow again one more time, and then I'm gonna ask the system to fetch the data. Okay, Okay, let's see. Okay, now the image shows sections of surface with blue and yellow stripe. In the background, there's a wooden pallet stacked near a wall. This setting could be part of the warehouse or industrial area. This is very, very true. As you can see that the system is working, and let's go ahead and break down the details. Okay, so without further ado, let's start with the system architecture. All right, so the first one is we have IsaacSim. Okay, and so let's say that this is basically the robot, and it publishes image, and the data type of the image is sensor messages image. Okay, so if you know how to use ROS2, then you can understand this really, really quick. But if you don't know, please go ahead and learn how to use ROS2. And the name of the topic, I believe, is camera front. Okay, slash. Yeah, and then I will receive joy. Okay, from joystick, and the data type is sensor messages and joy. Okay, and the name of the topic is joy as well. Okay, now we also have another node. This is basically the HTTP node. I'm gonna call it node. Yeah, so we got this I believe it's post. Okay, and then we have this get, and these go to n8n HTTP, as you saw earlier. Okay, and this one publishes joy. Okay, and then this subscribe to image. In this case is the camera front. Right? So the commands from n8n are forward, backward, shift, left, and right as well. Okay, what else? Rotate, left, rotate, right, and stop. Okay, oops, a little bit of a typo there. Okay, there we go. Stop. Yeah. Now, so this is what it does. We got this joy dot axis. I think forward and backward is basically 0. One is positive, one is negative, right? And then this one is gonna be joy dot axis, but this is gonna be, I think, I'm sorry, I make a mistake. So it's supposed to be something like this. It's 1, and this is 0. Now, the reason why we basically changed the index here is because normally when I do my IsaacSim control, I use PS5 joystick, and if you move forward, then that means we are accessing the axis, the second index, and if we want to do shifting in y direction, it's normally by using the first index. And for the rotate, it's gonna be joy, typo again, joy dot axis, but this one is gonna be the third one, or number 2. Yes, that one is on the right analog stick, right? So that's a PS5. But if you have Xbox One controller, that's completely different. For the stop itself, that means, oh yes, so basically the value is this one is 0.2 plus and minus, and this is plus and minus 0.2 For the rotate, I'll make it 1. And the unit is meter per second. This is meter per second as well. And this one is a radian per second. Okay. Now the stop is basically you set the all the axes 0 1 2 3 2 0 stop, right? Yeah. Now this is the bit where LLM is very good at, right? Because when it comes to understanding, this one is static, by the way. You can just simply uh, set that in n8n, saying that static commands, right? So you can say that in your chat, using Microsoft Teams, for instance, go straight. There is no straight in here, so that's where you specify from your AI a tool that you have to convert that fixed, into something like this. Let's say step back, and then the system will understand. Okay, I'm just gonna move backward, right? And then what else? Move in y direction plus, and then it will understand that, oh, you're gonna go to the left, shift left, right? Okay, and stop is quite straightforward, and then rotate as well. um can't really imagine any other words to describe that you have to rotate. Anyway, so yeah, so that's the system architecture, and let's go ahead and create our own workflow. Okay, now before we go to Microsoft Teams, let's just use normal chat. And the reason why we are using this is so that we can easily debug, and then once we succeed in using the workflow properly, then we can just um, replace this chat message with Microsoft Teams. Okay, and the second is gonna be AI, so it's gonna be AI agent. Okay, it's quite straightforward, and I'm gonna be using OpenAI chat model. GPT-4 Mini, I think is fine. Yep, we don't really need anything complex. I do not need memory because it's a very simple system anyway. And after that, what we need to do, we need to specify the system message, right? Okay, now let me copy and paste the one that I have created earlier. It's gonna be something like this. I'm gonna click this, okay, and explain this, right? So again, as I said, it has to be fixed strictly. So that's why I say it, right? So we got forward, backward, shift, left and right, rotate, left and right, and stop, right? If you change the upper lower case, it might be forward to straight. These commands won't work. Yeah, so we specify that quite clear that it has to be strictly like this. You can't just simply make it uppercase on. They have to be like strictly like this, lowercase, all of them. And the AI agent can't just simply change forward to straight. It has to be strictly forward, backward, etc. Right? So it's something that we have to specify in here as well. And we also need to tell the AI tool that once they receive the commands from user, and the system needs to go ahead and use the HTTP request tool. And if the user asks you to grab the image and robot velocity, use the fetch robot data tool. Yes, so we're gonna have two tools, right? The first one is gonna be HTTP request tool, and the second one is gonna be fetch the robot data. So let's go ahead with our HTTP tool then. Okay, so I think this is wrong. It's not supposed to be like this. And what else? Okay, so HTTP request tool. Okay, and the method is gonna be post, because we want to send command to the system. Let's have a look. So it's gonna be post, and the URL is gonna be something like this. This is my URL using rock, right? So what you have to do with this is you need to go to the portal, and then you get your the domain. Now, this is something that we specify ourselves, right? In our Python ROS2 node, we have this command, and if you use this URL, then that means, and especially post methodology, then it will send the data from the AI tool using HTTP to the ROS2 node, and then it will process the data, and then it will send command directly to ROS. Okay, and next we have to specify the command. So in this case, it's gonna be send body. We have JSON, and we got two things. So the first one is, oh, it's only one, sorry. So it's gonna be a command. Oops, this is wrong. And we let the AI set the value of the command, which is one of the strict commands that we specified earlier. Okay, I think this is okay. Okay, let's try that then. Right, let's give it a go. Okay, let me pull my IsaacSim window in here. Okay, let me make it right then. Okay, I think this one is it's okay, I would say. Okay, so can you? Oops, I can't really see anything. Can you move backward? Okay. Oh yes, we have to run uh the port forwarding, right? So let's pull this terminal again. Okay, so it's the software is running, but the like a proxy, it's not really a proxy. I'm not sure how to call this. Yeah. I'm struggling to pronounce this. If you know how to pronounce this properly, let me know. This one. 8,000, yeah. Right. Okay. There you go. So there you go. This is my domain, which is a free version. If you have like a paid version, that's gonna be something that you can create yourself. You can specify the name yourself. Yeah. Okay. Let me put this away and let me try that again. Copy and paste. I'm gonna say enter. Okay. There you go. It's moving backward, so it's working, right? So I'm gonna ask it to stop. There you go. Stops. This is much quicker, right? Because we don't have to click the execute workflow if we use Teams, and then it doesn't have to go to Teams first, and then it will receive this, and then it will process this afterwards. So that's why it's much faster. Okay, so this is has been great. This is yeah, it's working. That was easy. Okay, now the second one is gonna be um image processing, right? Um, let's go with the another um trigger actually. I think that's gonna be add another trigger. That's true. That's gonna be okay, something like this one. Yeah. So when executed by another workflow. Okay. The reason why is because we want to call this the whole workflow here, right? And this one is gonna be specific for image processing. So doing the I'm gonna call HTTP tool, and this time it's gonna be get, right? And the URL is gonna be similar, except that the subdomain is gonna be telemetry, right? It's gonna be telemetry. So we don't need to send anything because essentially we are gonna get the data from the ROS2 node, right? Okay, and it's gonna be image. So we need to convert the file from the image. This is base64 string. Yeah. And for this one, the input field is gonna be base image base64 JPEG. Right now, I can show you. So let's say if I call this, okay, what do we call that? Okay, if I, okay, let's have a look at the Python code a little bit right now. So essentially, this is it. So if you set the get, right, so this is the subdomain, you will receive velocity, x, y, and heading, and then the post as well, and the image, which is in string with base 64 uh, string data. So this is the only thing that we are interested in, especially for processing the image. And that's the reason why, if we go back, that's what you're gonna get everything basically. But then again, the only one that you are interested in to process the image is just this time. Okay. Next is we're gonna call OpenAI image. Um, okay, I'm just gonna go with this, and then that's gonna be analyze image. There you go. Yeah. Let me see, and the model is gonna be 4.0. That's gonna be binary files. All right. Yeah, I think that's it then. Right. Okay. So we're gonna save this, and we're gonna call this tool. So we're gonna click this, and we're gonna create it from the workflow. We need to remember the name of this workflow. So ROS2 experiment, right? So I'm gonna click this, and this is gonna be. Have we got this? Yes. There you go. Now, technically, well, I mean, like there are a lot of tutorials out there who, which can show you how exactly to use this tool. You can create this in another workflow file, and then when you call this call edit a workflow tool, and then you get it from the list, it can know that even though it's not at the same in the same file. Okay. So I'm gonna change the name to, according to this, is supposed to be where is it? Fetch the robot data. So I'm gonna change the name to something like this. Okay, rename. Is there anything else that we need to change? Oh, probably the description. Yeah. Okay. So then again, I'm gonna paste this. So just yeah. So this is very good information for the system, right? Uh, to tell the AI agent that this tool is specifically to make HTTP requests if the user asks you to fetch the robot data that includes velocity, pose, and the image, right? Okay, now let's try that again one more time. Okay, fetch the robot data, please. Okay, something's not right. Oh, it's probably here. Um, let's have a look. I think there's something that we forgot here, right? Accept all the data. Yeah, that's what we need, right? Because essentially, we are not sending anything to this, but what happened is the opposite. So basically the AI tool will decide to use this specific kind of workflow, and then it will just do the HTTP GET request, get the data, convert the data to the image analyzing, and then it will get the reply back to the AI tool, and then send it back to the chat tool. Okay, let's try again one more time. Okay, I'm not really sure what happened now then. Let's see, the problem is the reference issues. Okay, and source database. Let me see. Is that even the right name? Yeah, that's the right name. Hmm. Okay. It's probably somewhere. Okay. How about if we just play this, right? And then if I do it this way, do it this way, do it again. Okay, now we got it. So the image shows a large empty interior space with smooth dark floor. The walls will have brick, okay, and the ceiling features exposed. Can I shadow in the corner of the room? Okay, is that exactly what it's looking at? Let's go and click this and see the front. Something like that. I can see that. Yeah, it's a bit pointing downwards. That's how Boston Dynamics Spot is pointing the camera, the front camera, because they wanna use this not just only to see what's in front of it, but also to do the terrain navigation and recognition as well. Okay, now okay, we can try that again. Let's see what's the problem. Okay. Oh yes. Supposed to click paste. I was happy. There we go. It's the same one, isn't it? Yeah. Okay. Right. Okay. So in general, it's working. So I think what we need to do is to replace this with the Microsoft Teams. Okay. Final step. Let's change the chat message trigger to Teams. So I'm gonna delete this one, and then I can just simply copy and paste from our previous workflow. Okay. I'm gonna copy the notes. I'm gonna paste it here. Can I do this? There we go. We got it. We got them, and I'm gonna do this. Okay. And we also need the reply, right? So I'm gonna paste it here. Okay, and connect. Right. Now I will explain that a little bit later, but what I would do is I'm gonna save this and then I'm gonna execute the workflow. Okay, so this is the from the demonstration earlier. So I'm gonna click forward. Okay, it's quite happy. Okay, something is not right. Oh yes, gonna have to change this and gonna have to go with the um define below, because previously it's connected to chat trigger node, which is automatic. We don't need that anymore. Now I'm just gonna copy the content. Okay, we can try again. Execute again, forward, or try what, straight. Okay, okay, yeah, there we go. It's moving forward, as you can see this, right? Okay, now I'm gonna pull it, and then I'm gonna click stop. Okay, it's gonna hit the wall. It's hitting the wall already, but still trying to walk. Now stop. Great. Okay. So yep, it's as simple as that. And oh, I think now that we can see it, right? So the system stopped. I think there's one more thing that we can try now. Um, that's gonna be fetching the data, right? So okay, so I'm gonna pull this again, and I'm gonna stop it, right? Because I just don't really wanna, kind of move it back um to the original position by controlling it via text. Is gonna take ages. So I'm gonna play, okay, and then I'm gonna say fetch the data. Let's see. Yeah, there we go. Let's see what I have fetched the data. The image shows an empty room with a dark blue floor. That has visible scratches or markings. There you go, it's working. And let's have a look. Okay, so this is gonna be, so this is the trigger, right? And from the previous video, don't forget to include your credential, and the trigger is gonna be on chat message and watch all chats. So what happened here is that in Microsoft Teams, you've got multiple chats, and what you want is actually everything, not just only one. Okay, and if I can do this, that's gonna be, so you can see that we got the chat ID, right? And we also have this data ID. Okay, that's the reason why we need to go to code, because we really want to extract this ID here, because this ID indicates a person who is sending a message to our bot, right? And we got the code over here, which I'm gonna share with everyone in the description below. And the output is message ID and chat ID. And then after that, we will get the message. So this is the bit which I'm not really a big fan of Microsoft Teams, because if you use something like Telegram, you can just simply get the chat as simple as that, but not with Microsoft Teams. Okay, and we have and this one is in HTML, which is a bit strange as well. And then you basically put the chat ID from this one, which is this is the parsed chat ID, and then you will get the message, all the information that you need from the message, right? Then you have the AI agent, and then you're gonna use the content as the input for the AI agent, and then it will execute the commands in this case. And then once it's done, it will send the reply from the output, right? And in this case, it's the same. So the chat is going to be the ID, which is actually from the code, the JavaScript code, and then the output that you will send to the person who sent a message to you, to the bot, is going to be the output from the AI. Okay. Now, the last thing that we need to look at is the Python code. Then again, don't worry too much about it. I'm gonna share the code in the description below. But let's have a look at it so that we can understand what's happening from the HTTP ROS2 node in Python. Okay, so I'm gonna do this, and I'm gonna open the file. That's gonna be I think the name. Okay, yeah. Okay, so this is the code, and so we got this class which is basically derived from ROS2 node, and we have a publisher and we have subscription. So the subscription is essentially the odometry data from Spot, and that includes twist and position. That includes linear and angular. But then again, this is still a mobile robotic system, so we only care about x, y, and z, x, y, and z. And the z is just the angular, right? It's not really z in linear, because we assume that it's going to be always on the ground, it's not flying, and that's for the velocity. And we have position, and position is the same, so it's going to be x, y, and heading or yaw. That's what we take and we subscribe to, and we send back to n8n, and then after that Microsoft Teams if we ask this data. And for the image is RGB front, so I made a mistake earlier. I thought it was camera front, but it turns out that it is RGB front. My apologize. I My apologies. Sorry. Um, and then we subscribe to this topic, which is image, and we will get it. And then this one is going to be, so we are going to be using bridge, CV2 bridge, and then we will convert from the ROS2 message to CV2. So it's OpenCV. And then once we have this in array, which is in NumPy normally, then we will encode this into JPEG, right? And then we will transform this into a base64 format, which is gonna be in string, so that we can stream this data via HTTP. And the resolution is also quite low, which is only 200 by 200, I think, if I'm wrong. Okay, once we have that, we also create the publisher for sending the command using joy access. There are three, I think I've explained earlier. So the second index is going to be x, the first index is going to be y, and then the third index, which is the index number 2, is going to be the heading, which is the yaw, counterclockwise or clockwise, something like that. And in this case, I changed the number from 0.2, I think, from my earlier video into 1. You can change that to anything. It's just the speed, basically, in meters per second. If you want to move it faster, then go faster. If you want to move it slower, then go slower. As simple as that. Okay, and then we'll publish this. Okay. What am I missing? So yeah, I think that's all. So this is send command. The send command bit is gonna be called. Let's have a look. Yeah, something. Yeah, it's basically here. And so for the HTTP post and get, we use this Python library called fast API. And so we have this command, which is post, and then we have this telemetry, which is get, right? And when we receive the post, HTTP post from n8n, what happens is we call this function, and then we send the command based on the JSON data that we send from n8n to this ROS, and then we'll return the status and the command that is received. And after that, for telemetry, it's just simply get. And once we have the HTTP get telemetry for the subdomain, I think that's what it's called. And it will return the velocity, pose, and the image, basically from what we subscribed earlier from telemetry and the image. Okay, and then obviously, because we need the ROS node to keep subscribing and publishing, especially subscribing, that's why we choose spin, so that it will automatically execute this every time we receive the image data and odometry data. That's why we call this spin, right? And yeah, for the spin itself is part of the thread. And then so uvcorn.run. Yeah, so uvcorn is part of the Python library to run the HTTP server. And so for the addresses, we just uh, broadcast this application to any kind of IP address that we have. So if you open the port, you forward the port manually using your router, then this is going to work as well. But then again, your IP address is going to be public IP address, and normally, like a normal internet provider, they're just going to change that in certain time. So that's the reason why we use this grok, right? There you go, so that we can forward the port, and then allow this domain to just access this particular port to our system, so that we can receive HTTP post and get from n8n. Okay, I think that's all. I hope you guys enjoy this video, and thank you very much.